Hello everyone. Good afternoon to all. Okay, guys, let me know in the chat box whether my voice and my screen is everything is clear or not. Let me know in the chat box whether my voice is clearly audible to you all or not, and also my let me know in the chat box whether my voice screen is visible clearly or not. Respond in the chat box, everyone, please. Everything is clear to start class. Everything is good. Shall I start the class? Okay. 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 Hello everyone. Welcome to your class. So today we are going to start new chapter, or we'll discuss previous year question papers of definite integration. Okay. So previously we have completed the topic, that is application of derivative. We already have completed this chapter. Okay. Application of derivative. Already you have completed. Okay. So now we'll continue the chapter, that is definite integration. Okay, so in perspective of JEE Advanced, this paper is very, this chapter is very much important, because in 2019 also 3 questions came in 2019. In 2019, 3 questions came from this chapter in JEE Advanced, in both paper 1 and paper 2. Okay, and also you can see, you can observe also from the analysis, analyzed data of JEE Advanced. So previously JEE Advanced giving me more important to this topic actually. So basically from indefinite integrations, few questions are coming. Sometimes one questions it can be come, but mostly from integral calculus, or you can say from indefinite and definite, as comparison to indefinite, from definite integrations, questions are coming in JEE Advanced. In that perspective, this chapter is very much important for your advanced examination. Okay. Okay. So what we'll do, we'll first discuss all the properties of definite integration. So you know, all of you, key to solve the definite integrations, we must have idea about all the properties of definite integrations, and also we must have an idea about how to evaluate the indefinite integral. So you must have conceptual knowledge of, or to solve or to evaluate the indefinite integrals. Those concepts or those process or those things will be helpful in problem solving in definite integrations also. What we'll do in definite integrations, basically we'll evaluate the integration and we'll put the limit, and also we'll in case of area under the curve, we'll find the area. Okay, so let's start from the properties of definite integrations. Okay, you can see in your screen the first property, the very basic property, that is change of dummy variable in place of x. Suppose you have integral f of x from a to b with respect to x. It can be, or it is same as to integrate the function f of t from limit a to b. If you change the if we are changing the variable, there will be no change in the value of the integral. Okay. Second property, if you are interchanging the limits, then minus negative sign will be multiplied with that integral. Okay. And the third property is, if you'll try to, you can break the intervals, or you can break the limits given in the definite integrations. Okay. Suppose here it is given integration from a to b f of x dx. So it can be break into two integrals, where c belongs to the interval ab, and integration a to c f of x dx plus integration c to b f of x dx. Is that clear? Okay. So these are three basic properties of definite integrations, all of you know. Okay. Let's move to the next three properties also. And here, if you have a odd function or even function, so in case of definite integrations, what should you do? In case of definite integrations, when you are having a limit like minus a to a f of x dx, and if you know this given function is an odd function, that means f of minus x is giving you minus of f of x, then blindly you can say the integration or the integral of this integral will be giving you the value as 0, right? If it is even function, if it is odd and the limits are minus a to a, then the value of the integral is 0. If it is an even function, what should you do? The property is 2 into 0 to a f of x dx. Yes, if f of x is an even function. Clear? Okay, come to the fifth property. Fifth property is saying the most important property, that is, we know this property is known as king property. King property, king between the properties, all the properties of definite integrations. Okay, so see, integration a to b f of x dx, right? It can be written as also integration a to b f of lower limit plus upper limit minus x dx. That means what we are doing, we are substituting x as lower limit plus upper limit minus x. Is that clear? Okay. This one is very much important property, and this is known as my king property or king property. Okay. And come to the sixth one, what it is saying, integration 0 to 2a, right? Integration 0 to 2a f of x dx. So it can be also written as 0 to a f of x plus f of 2a minus x dx, right? So when f of 2a minus x is equal to f minus of f of x, then the integration gives you 0. If f of 2a minus x is equal to f of x, then the integral will be 2 into 0 to a. Instead of 2a, you are taking a here and you are multiplying 2 here. Okay. So these are 6 properties we have discussed. Now there is a shortcut. It's a note for you, and it is important also. Integration a to b f of x dx upon f of x plus f of a plus b minus x. This is a shortcut. Remember, it's a shortcut when you are applying the king property or property number 5. When you are applying property number 5, or that is integration a to b f of x dx is equal to integration a to b f of a plus b minus x dx. Okay, so when you are applying this property directly, you can write, if you have a function in this format, so directly this integral will be half into b minus a. We'll solve some questions on this result also, right? That is b. What is b? B is your upper limit and a is your lower limit divided by 2 is your integral, value of the integration. Okay, let's move last one. Next one is periodic function. F is a periodic function, then with period t. If f of x is a periodic function with period t, then how we can integrate these periodic functions? Okay, we'll discuss when we'll discuss the questions on this concept. We'll discuss the problem properties also, right? So let's move. This is estimation of integrals. Like it's a result. You can see here also, and when we'll discuss problems on these concepts, we'll discuss this. So, okay, this is also another thing. Okay, let's solve this question. Let's solve this question. Okay, what it is showing. This is a question came in 2020, I think. Okay, 2020. Yes, 2020 JEE advanced question है. ठीक है. So which of the following inequalities is or are correct? How many of you solved this previously? Because basically it's a previous year question. So most of you, I hope most of you solved this type of questions previously, right? If any one of you have solved this question, can you please respond in the chat box? What is the answer of this question? Everyone? Okay, no problem. So what is the way to solve this question? So all of you know, guys, all of you know what is the series expansion of sin x? All of you know what is the series expansion of sin x? That is x minus x cube upon 3 factorial. When you studied limit, you have covered all these series expansions, right? And also in limit you have covered all this series expansion. So x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and so on. So this is mine. Then x to the power 7 by 7 factorial also and so on. This is my series expansion of sin x. And if I'll ask you to tell me what is the series expansion of cos x, it will be 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial and so on. So this is the series expansion of cos x. So these are two series expansions of sin x and cos x respectively. Okay. So let's use this series expansion and try to solve this question. So to solve these questions, we'll go through all the options one by one. First, in the first option, it is given that because it's a multiple correct answer type question. So in the first option, it is given that integration from 0 to 1 x cos x dx is greater than equal to 3 by 8. So how we can prove it? Achha, tell me one thing. From this series, in between sin x and x minus x cube by 3. So which is greater? Obviously, because with this bracket, so many terms or infinite number of terms are added, right? So obviously we can say sin x is greater than x minus x cube by 3 factorial. Yes or no? है ना? So similarly, from the second series also we can say cos x is greater than 1 minus x square by 2 factorial. Okay. To prove the first inequality, to verify the first option, what we'll do, guys? First option, it is given that 0 to 1 integration x cos x dx is greater than equal to 3 by 8. So how we can verify it? Let's take this option A. Okay. So we know from the series expansion, we know cos x is greater than 1 minus x square by 2 factorial. Okay. 1 minus x square by 2 factorial. Okay. So if we will multiply x on both sides, so what will happen? If we will multiply x on both sides, what will happen? X into cos x is greater than x into 1 minus x square by 2 factorial. So this becomes actually x cos x is greater than x minus x cube by 2. Yes or no? So if I'll ask you to integrate both sides with respect to x, okay. If we'll integrate both sides from 0 to 1 on both sides with respect to x cos x dx will be greater than equal to, greater than integration from 0 to 1 x minus x cube by 4 2 dx, right? So if we'll evaluate the right hand side inequally, right hand side integral, so what will happen? Let's see. This is greater than 0 to 1. The integration of x is, chalo at a time कर लेते हैं. Integration of x is x square by 2 minus 1 by 2 and x cube की integration जो है that is x to the power 4 upon 4, right? And limit क्या है? 0 to 1. ठीक है? So this is basically when we'll apply the limit, it will be 1 by 2 minus 1 by 2 minus 1 by 8, because when you put the lower limit 0, it will be giving you 0. So 1 by 2 minus 8 is 8, that is 4 minus 1, so 3 by 8. So here we are getting, finally we are getting integration 0 to 1 x cos x dx is greater than 3 by 8. That means my step option A is correct. Yes, option A is correct. Yes or no? Okay, so option A is correct. Okay, let's come to the second option. Achha. If you come to the second option, what is happening here? Let's see. Second option में ये दिया है. Okay. Second option में दिया है integration 0 to 1 x sin x dx is greater than equal to 3 by 2. Oh, this is given that greater than equal to, no problem. We can just put just let me check in the question. Just a minute, guys. Yeah. Yeah. So this is given that greater than equal to. So we can take this similarly here also we can take greater than equal to, no problem. Okay, just rectify this is greater than equal to. Okay, in all the cases you have to take greater than equal to. Okay, sure. So move to the second thing, second option. What is happening with the second option? This is greater than equal to, we need to prove which is greater than equal to 3 by 10. Let's check 3 by 10, and we know sin x is greater than equal to, or sin x is greater than x minus x cube by 3 factorial, or if when you will multiply x sin x, it will be x greater than equal to x square minus x to the power 4 by 6, right? And if you will integrate from 0 to 1 x sin x with respect to x, it will be 0 to 1 x square minus x to the power 4 by 6 dx, right? Check. Now use a similar process and try to integrate it. It will be greater than equal to 0 to 1. So if you will integrate x square, what you are getting actually? If you integrate x square, what you are getting, guys? We are getting x to the power 3 by 3 minus 1 by 6 into x to the power 5 by 5. Okay? Okay. And put the limit here also. So this will be 1 by 3 minus 1 by 30. 1 by 3 minus 1 by 30, 0 put करेंगे तो 0 आ जाएगा. So this is equal to 30 and 10 minus 1. So 9 by 30 it is coming. Okay. 9 by 30 it is coming, which is 3 by 10. Okay. So it is also correct. Option B is also correct. Right. You can observe option B is also correct. That means it is also correct. So option B is correct. Let's come to the option C. Let's come to the option C now. So in option C, what is it? What it is given? X square cos x, right? X square cos x greater than equal to 1 by 2. Okay, so take option C, 0 to 1 x square cos x dx, which is greater than equal to 1 by 2. This we need to verify. So let's all of you know, so a cos x is greater than cos, if we'll take cos x is greater than equal to, what is it, 1 minus x square by 2. If we'll multiply x square with this also and with this also, what we are getting, x square cos x is greater than equal to x square minus x to the power 4 by 2. Is that or not? So if you integrate from 0 to 1 on both sides with respect to x, okay, so what we are getting, let's see, we are getting this is equal to x cube by 3 minus 1 by 2 into x to the power 5 by 5. So if we put the limit here 0 to 1, we are getting 1 by 3 minus 1 by 10. So this is equal to actually 30, and it will be 10 minus 3, which is 7 by 30. So it's wrong actually. Option C is wrong. Option C is wrong. So option C is wrong. Come to option D. How we can verify option D also? Here it is given that x square sin x, integral of x square sin x from 0 to 1 is greater than equal to 2 by 9. Right? So let's check for it also. Let's check for it also. X square sin x 2 by 9. Okay. X square integration option D 0 to 1 x square sin x dx, which is greater than equal to 2 by 9. We need to verify this statement. So all of you know sin x from the result, from the series we know sin x is greater than equal to x minus, what is that? It is x or what? X minus x cube by 3 factorial. So if you multiply x square on both sides, what we are getting? We are getting x square sin x is greater than equal to x cube minus x to the power 5 by 6. Okay, now integrate from 0 to 1 on both sides. What you are getting? Let's see. If I integrate this, we are getting x to the power 4 by 4 minus 1 by 6, x to the power 6 by 6. Okay. So if we put the limit also here, we are getting 1 by 4 minus, oh, this is 5, x to the power 5 by, yeah, okay. You are getting 1 by 36. So 1 by 36, 36 is your LCM, 9 plus 1, 10 by 36. So 10 by 36, 2 by 9, okay, 10 by 36 we are getting. Let me check again, guys. Yes, it is clear. 1 by 4 minus 9. Oh, this is minus. No? I'm sorry. This is minus. So in the answer, you are getting 8 by 36 and it will be equal to 2 by 9. So this is correct. Option D is also correct. So here in the first question, we are getting 3 correct answers. This option A, B and D. Okay. थोड़ा लेंथी है, बाकी अच्छा क्वेश्चन है, तुम कर सकते हो ये क्वेश्चन को अगर ये तुम्हारे दिमाग में है तो. So you must have remember all the series expansion of when you are going to JEE advanced examination. You must remember all the concept. Okay. Sure. ठीक है. So first question is done. Come to the second question. Is there any doubt, guys? You can ask also. If you have any doubt, you can ask. Done. Sure. So let's move to the next question. Now we'll discuss. All of you know what is Leibniz theorem. Leibniz theorem. All of you know or not? So it's already written in already available in your screen. Okay. So this is actually my Leibniz theorem. Most important theorem. In perspective of JEE Advanced also means this theorem is very, very important. Okay. So if capital F of x is equal to integration from g of x to h of x f of t dt, then if I'll ask you to find f dash of x, so how can you find? So simply in simple language, when this type of expressions you are given, integral expression you have given, and if it is asking to find f dash of x, so how can you find? So simply f dash of x will be f of, f of x is f of t is given, so f of h of x, that means f of h of x is your upper limit, f of h of x, f of upper limit into derivative of upper limit, that is h dash of x, minus f of lower limit, that is f of g of x into derivative of lower limit. Okay, so this is simply my Leibniz theorem is saying if it is given, such type of expression is given, right? So let's solve one questions on this theorem. So let's see how many of you are able to solve this type of questions also. Let's discuss the first question on this theorem. It's a JEE questions of 2010, right? So how can you integrate this function? Simple. It's very simple question, came in 2010 JEE advanced examination. So the value of it is given, it is asking to find limit extending to 0, 1 upon x cube. Okay, so it is given that limit extending to 0, 1 upon x cube, 0 to x, ln of t into ln of t into ln of 1 plus t divided by t to the power 4 plus 4. Okay, so how can you guys, how we can integrate? फर्स्ट तो ये दिमाग में आना चाहिए कि how we can integrate this or how we can evaluate this integral. This is important, right? So here you can observe in the limit portion you are given some functions, right? 0 and x, that is variable are present here. Variable are present here. So how we can evaluate the limit, or how we can evaluate the integral? Let's see. So how can we write this as, if we'll use the Leibniz theorem directly here. Okay, can we write this as limit extending to 0, integration 0 to x t ln of 1 plus t divided by t to the power 4 plus 4 by x cube dt, because x cube is here na present. Okay, so we can write or not. So guys, let's see. Let's see. We need to evaluate the limit, na, right? So how we can find? So if we'll calculate the integral, let's see. Denominator is 0. When you are putting the limit, denominator becomes 0. But numerator, what is happening with numerator? Numerator is actually 0 to x. Now, if you integrate this, what you are getting? Ln of x into ln of 1 plus x by. Okay, it is in 0 by 0 form. Yes, so t t into limit. When you are putting 0 extending to 0, so it is in 0 by 0 form or not? If evaluate the limit also, if you integrate first, integrate, try to integrate this. Okay, so let's solve this one. Limit extending to 0, we'll use the Leibniz theorem here in the denominator. What is happening? Let's see. So that is f of h of x. So upper limit is given as x here. So in place of t only you need to substitute x. So this becomes x into ln of 1 plus x, f of x, f of h of x, and here h of x is x. So in place of t we need to substitute only x. So x into ln of 1 plus x upon x to the power 4 plus 4, okay, minus into or b hai na, we need to multiply also the derivative of upper limit, that is 1, minus f of g of x, and here g lower limit is 0. If lower limit is 0, if we will put in place of t, if we will put 0, so it will be 0. So 0 into 0. ठीक है, you are getting. ठीक है. Okay, so now you can see, if we put extending to 0, this will be coming in 0 by 0 form. Yes, so we are getting 0 by 0 form or not? Okay, so we are getting 0 by 0 form. So what we are doing here actually, we did actually here we are getting 0 by 0 form, right? Here we are getting 0 by 0 form. Okay, and now after getting 0 by 0 form, we have used here the L'Hopital rule. Now use the L'Hopital rule. If you use the L'Hopital rule here in this, okay, we'll use the L'Hopital rule here. So what is happening? We need to differentiate the numerator and also we need to differentiate the denominator. So if we'll differentiate the denominator, what is happening? 3x square you are getting 3x square, right? So numerator becomes this and denominator becomes 3x square. Okay, कोई नहीं. Okay, so all of you understood how this comes from 0 by 0 form, because here we are putting the limit. When we are putting the limits, this lower this upper limit becomes 0 or not? If this upper limit becomes 0, so integration from 0 to 0 of any integral will be 0. So this is of the form 0 by 0, because when you are putting limit extending to 0, this upper limit becomes 0. So 0, when we are integrating any function from 0 to 0, so this will be giving you 0. So denominator is already 0 and numerator becomes 0. So 0 by 0 form. So now we can use to evaluate the limit, we need to use the L'Hopital rule, and by using the L'Hopital rule, when you are using the L'Hopital rule, we need to differentiate the numerator first and denominator first. Now after differentiating the numerator and denominator, let's put the limit again, whether you are getting a finite limit or not. Let's check whether you are getting a finite limit or not. So check when you are putting, okay, here x square. So if you write this as cleanly, extending to 0, x ln of 1 plus x divided by 3x square into x to the power 4 plus 4. So from here x will be cancelled out. Yeah, x will be cancelled out. So now if x is cancelled out, so 1 by 3 को मैं बाहर ले लिया. So limit extending to 0, what you are getting? Ln of ln of 1 plus x divided by x to the power 4. X to the power 4 you are having again x to the power 4 plus 4 into x you are getting. Okay. Now we can write this as 1 by 3 into limit extending to 0 ln of 1 plus x divided by x into 1 upon x to the power 4 plus 4. Yes or no? We can write or not. So all of you know this limit is actually 1 ln of 1 plus x by x when extending to 0 gives you 1 always. So we are getting, we will put the limit 1 by 3 into, here we will put the limit 1 by 4. So the correct answer is 1 by 12. So correct answer is 1 by 12, right? So correct option is option B. 1 by 12 is your correct answer. If you have any doubt, you can ask. I hope this is a very simple question. You understood this in 2 days. Respond in the chat box whether it is clear or not. Is there any doubt? What we did actually, we used the Leibniz theorem here only, nothing else. First, we have studied whether it is asking to find the limit of this integral. Okay, when you are finding the limit, you must have checked what is the form of the function, what is the form of the limit is given. So when we are checking, when we'll check, so the given limit is in the form of 0 by 0, right? So how it becomes 0 by 0 form? Because denominator becomes already 0 because x cube is present in the denominator. When we will put limit, so x cube is also 0. And how it becomes numerator becomes 0? So because when you will put the limit extending to 0, so upper limit x changes to 0 and integration from 0 to 0 is always 0. So 0 by 0 form, we got 0 by 0 form. Then we use the Leibniz theorem because in the limit section you are having the variable or functions 0x. So what is Leibniz theorem saying? F dash of x is equal to f of h of x, upper limit f of upper limit into derivative of upper limit minus f of g of x or f of lower limit into derivative of lower limit. Okay, so same thing we did only, nothing else. Then we simplify this integral to this. Okay, then using the standard result, we know ln of 1 plus x when extending to 0, limit extending to 0, it will give you 1. Okay, and when we put limit in 1 upon x square, x to the power 4 plus 4, we are getting 1 by 4. So 1 by 3 into 1 by 4 is 1 by 12. Clear, everyone? Clear? Tell me. Clear? Okay. If it is clear, let's move to the next question. Here you have the question. Here also we'll use the Leibniz theorem, and it's a question. It's also 2010, and it's a question of 2014 JEE Advanced. Okay, it's a question based on Leibniz theorem also. So can you solve it? And it's a multiple correct answer type question. Okay, it is given in the question f is a function which is mapping from 0 infinity to r, and it is given by integration f of x is given as integration 1 by x to x e to the power minus t plus 1 by t dt. Okay, so this is the integration is given. Okay, function is given. So then we'll check all the options one by one. Let's check. First option, it is given that f of x is monotonically increasing function in the interval 1 to infinity. Okay, so how we can check whether a function is monotonically increasing or it is monotonically decreasing? By finding the first derivative of that function. So f of x is already given, so we need to find the first derivative of the function. So if you go through the first option. If you differentiate the function f of x, so what you are having, what you are getting, if you will integrate the, sorry, differentiate the given function, we are getting d by dx of integral of 1 by x to x e to the power minus of t plus 1 by t divided by t dt, right? Okay, now you can easily differentiate this function or not? Yes, we can easily differentiate this function because it is given. How we can differentiate this function? You can use a Leibniz theorem here, because the low limits, upper limit and lower limits are given in the form of variable. Okay, so if you use the Leibniz theorem here, so this will be f of h of x. So in case of t, you need to replace the upper limit. So it is given as e to the power minus of x plus 1 by x divided by x, okay, into derivative of limit, upper limit, that is 1, okay, minus f of g of x, that is f of just in place of t, you need to substitute 1 by x. So you are getting minus of 1 upon x plus 1 by 1 upon x becomes x. So this will be also 1 by x. Okay, and derivative of 1 by x is minus 1 upon x square. Okay, so this is the function you are getting after differentiating the given integral. Okay, chalo, let's see here. X, 1x will be cancelled out, right? So finally we are getting, you can observe here, finally we are getting 2 into e raised to minus of x plus 1 by x divided by x. Yes or no? This is you are getting or not? Tell me. Or this will be minus, minus will be plus, and in the numerator both are same, na? And also in the denominator after cancelling x here. Okay, so you are getting this 2 into e to the power minus of x plus 1 by x upon x. Achha. So what is the interval in the option A? What is the interval given? 1 to infinity. So this is my f dash of x. You got f dash of x as this. Okay, so you need to check whether in the interval 1 to infinity, in the interval 1 to infinity, it is positive or not. Oh, so in the interval in 1 to infinity, exponential function is always positive. That means numerator becomes positive, always positive, and denominator is also positive because in denominator you are having x. In the denominator you are having x, and if you take the value of x in between 1 to infinity, that means we are taking the positive real numbers for x, then also denominator becomes also positive. Always exponential function is positive, this is positive, and this is also positive. Denominator positive, this is positive, 2 is given as positive. So f dash of x is positive, greater than 0. That means f of x is increasing function. We know from the application of derivative, all of you know na, if the first derivative of the function is greater than 0, that means that function is monotonically increasing function. So in the interval 1 to infinity, that means hence we can say f of x is monotonically increasing in 1 to infinity. Clear? Clear? Okay. Now, so first option is correct. Sure. Okay. So first option is correct. Come to the second function. Now we need to check b f of x is monotonically decreasing in 0 to 1. Achha. So the same function, but the same function in the interval 0 to in the interval 0 to 1. Okay. In the interval 0 to 1, f dash of x. Study the function f dash of x. Numerator is always positive because in the numerator you are having exponential function, and exponential function gives you always positive value. And also in the given interval, all if any point you will take a positive value. So for a positive value from the interval 0 to 1, if you put any point in between 0 to 1 for x, so denominator becomes also positive. That means here also f dash of x is greater than 0. F dash of x is greater than 0, that means f of x is जो है ना, that is monotonically increasing in 0 to 1. Monotonically increasing in 0 to 1. But in the given option, it is given that, but in the given question, it is given that option B, it is given that f of x is monotonically decreasing in the interval 0 to 1. No, it's wrong. So option B is wrong. Option B is wrong. Okay. So if option B is wrong, next, now we'll move through the third option. So what is given in the third option? That is f of x plus f of 1 by x, right? F of x, option C, f of x plus f of 1 by x is equal to 0 for all x belongs to 0 to infinity. So this is equal to 0 for all x belongs to 0 to infinity. Is it true? So let's check. In the for the function, it is given that okay, integration 1 by x to x. So f of x becomes integration 1 by x to x. It is already given. So e to the power. So e to the power minus of t plus 1 by t. Because we need to find f of x. So we should not interfere with the variable t, because we don't have any relation with the t, because we need to find only f of x. So where x is present, minus of plus 1 by t upon t dt, right? Plus, now we can change this f of, in place of x, we need to find f of 1 by x. So in place of x, where you are having x, you need to substitute, in place of x, you need to substitute 1 by x. So if you put 1 by x here, in the lower limit, if you put 1 by x, so this becomes 1 by x, that is x2, and in place of x, if you put 1 by x, this becomes 1 by x. So this will be remain same, e to the power minus of t plus 1 by t divided by t dt. Okay. Now see, from the properties of definite integration, we know if we'll interchange the limit, then we have to multiply -1 with that integral. Okay. So this is remains same, t plus 1 by t divided by t dt. Here we are interchanging the limit. That's why I will multiply, or I am multiplying my -1 with that integral. So this becomes 1 by x to x e to the power minus of t plus 1 by t dt. Now you can see, or you can check, both the integrals are same. That means this is equal to 0. Yes, option C is correct. Guys, option C is correct. Okay. So option C is correct. Now come to option D. What is it? What it is given? In option D, we need to check f of 2 raised to x is an odd function. Okay. So for option D, let's check for option D. F of 2 raised to x. F of 2 raised to x is an odd function. है ना? So in the third option or option C, we got f of x plus f of 1 by x is equal to 0. That means it's an odd function. है ना? How can you check? How can you check? So this will be actually, it becomes 1 by 2 raised to x. Okay, and this becomes 2 raised to x e to the power minus of t plus 1 by t divided by t dt. Okay, so this is my f of 2 raised to minus x. If you put f of 2 raised to minus x, so it will be 1 upon 2 raised to minus x, and this will be 2 raised to minus x, right? So this will be remain same, e raised to minus of t plus 1 by t divided by t dt. Now you can see, so my lower limit becomes 1 by 2 raised to x, that is 2 raised to x, and my upper limit becomes 1 by 2 raised to x. Okay, and the function inside function will remain same, e to the power t plus 1 by t divided by t dt. Okay, now if I'll ask you to change the limit, interchange the limit of the final integral. Okay, so if we'll interchange the limit, that means we need to multiply minus. Okay, multiply minus here. So that means this will give you 1 by 2 raised to x, 2 raised to x, e to the power minus of t plus 1 by t divided by t dt. Now you can observe here, what is the integral you are getting now? This is my f of x. Okay, this is my f of 2 raised to x. Okay, so we are getting finally f of 2 raised to minus x is equal to minus of f of 2 raised to minus x. That means it is satisfying my properties of or conditions for a function to be odd function. That means it is, hence f of 2 raised to x is an odd function. Clear? It is an odd function. So option D is also correct. Okay, so option D is also correct. So in these questions, 3 options are correct. Option A is correct, B is correct, D is correct, except option option B is wrong. Option B is wrong, other options are correct. Clear? If you have any doubt in these questions regarding any concept or anything you are having any doubt, you can ask here, everyone. Quickly, any doubt you are having, any doubt you can ask here. No doubt? Okay. So move to the next question. Okay. In this question, it is asking to find. Okay. It is given that f of f is a function which is mapping from R to R, be a differential function such that its derivative f dash is continuous. Okay. So f is a function which is mapping from R to R. ठीक है, चलो कोई नहीं, it's a function which is mapping from R to R, and f dash is continuous, and it is given that f of pi is minus 6. Okay, f of pi is minus 6, and capital F, which is mapping from 0 to pi closed interval to R, and also it is defined by capital F of x is defined by 0 to x f of t dt, right? And it is also given that integral 0 to pi f dash of x plus f of x cos x dx is equal to 2. So you need to find f of 0. It's a question came in 2020 JEE Advanced. So how we can solve this? How we can find f of 0? Clear? A very good question came in 2020 JEE Advanced. So let's solve this question. Okay. Okay. So in the question it is given that capital F of x is defined as 0 to x f of t dt, right? F of t dt, 0 to x. And we know Leibniz theorem, if you use, and if you ask you to find f dash of x, capital F dash of x. So how we can find capital F dash of x? So it will be f of upper limit, that is f of x, into derivative of upper limit, that is 1, minus f of lower limit into derivative of lower limit, that is f dash, capital F dash of x we are getting, that is f of small f of x. So simply we are getting here capital F of x is equal to small f of x. It's a very good results we are getting here. Okay, so what is capital F of x? It's a integral of small f of x. Okay, what is capital F of x? It's integral of small f of x. Remember. Okay, here we got this results. Now also in the question we are having 0 to pi. We'll take this portion. Okay. Also, it is given that 0 to pi f dash of x plus capital F of x cos x is equal to 2. Okay, if you open this, what you are getting? 0 to pi f dash of x cos x dx plus we are getting 0 to pi integration 0 to pi capital F of x cos x dx. Okay, so here we are getting two integrals, right? Here we are getting two integrals. ओके अगर मैं तुम्हें ये पूछूं कि अगर तुम्हें कभी भी दो फंक्शन की इंटीग्रेशन पूछे तो हम कौन सी मेथड यूज करें? हम यहाँ कौन सी मेथड यूज करना चाहिए हमको? Which method we should use here to relate the integral? Two integrals we are getting here, right? Two integrals we are getting here, but in each interval we are having two functions, product of two functions, f dash of x cos x, capital F of x cos x, right? Okay, so what is the method we should use? So integration by parts, right? Integration by parts we will use to solve these two integrals. So let's solve. Chalo, okay. So for the first integral, to which function we should take the first function and which function we should take the second function. That is important. So which function can be easily integrable, we must take that function as my first function, and which function can be easily differentiable, we should take that function as my second function. Is that clear? Okay. So I am taking which can be easily integrable, we should take that function as my second function. Sorry, we should take that function my second function, and which function is can be easily differentiable. That is, yes, we should take that function as my first function. So we know the differentiation of cos x, and easily we can integrate f dash of x. So I am taking cos x as my first function and f dash of x as my second function. Okay, come to the second integral. Here we know differentiation of f dash of x. All of you know what is differentiation of f dash of x. Already we got, that is small of f of x, right? Small of f of x. Okay, so it can be easily differentiable. So this function we am taking this function as my first function, because it is easily differentiable, and cos x, it can be easily integrable, my second function. So let's apply the method by parts to evaluate the integral. So first function, that is cos of x into integral of second function. So integration of f dash of x dx minus बड़ा वाला integration of differentiation of first function, that is cos x differentiation of cos x, that is minus of sin x, into integration of second function, that is f of x dx. Okay, chalo, okay, this is for my first integral. Okay, now come to the second integral. If we'll come to the second integral, let's see. Second integral के लिए we are using, okay, so first function is capital F of x into integration of cos x is sin x minus बड़ा वाला integration, that is differentiation of first function, that is capital F of x की differentiation small f of x into cos x की जो integration है, that is sin x dx. Okay, चलो. So you can observe here, this minus minus will be plus. Okay, so you can see these two integral will be cancel out each other, है ना? So these two will be integral. These two integrals will be cancel out. Then what we are having finally? We are having finally cos of x into integration of f dash of x is small f of x plus capital F of x into sin of x, right? So these things you are having now. Okay, so this is my integral. Finally, what should you do? You must use the limit na 0 to pi. If you use a limit here, what you are getting? Let's put the limit. So cos of pi is -1. Cos of pi is -1. F of pi plus capital F of pi into sin of pi, which is 0. And when we will put the lower limit, cos 0 is 1. Okay, so cos 0 into f of 0 minus capital F of 0 into sin 0. So ये दोनों तो 0 हो जाएंगे ना, sin pi is 0, this is also 0. So finally, we are having minus of f of pi minus cos 0 is 1, f of 0. So f of pi is given in the question. F of pi is given in the question, that is -6. Oh, it is given already, na? It is already given in the question. It is 2. Hai na? This integration is equal to 2. It is given that this is equal to 2. Then, and already it is f of pi is -6. It is given. So this 6 minus 2 is equal to f of 0. So my f of 0 becomes 4. So this is my answer. So f of 0 I am getting f of 0. Answer of f of 0 is 4. And I hope this is clear to all of you. Is there any doubt you can ask? If you have any doubt, you can ask. क्लियर? कोई भी डाउट हो तो पूछ सकते हो. सो आंसर क्या मिला मुझे? दैट इज 4. कोई भी डाउट हो तो पूछ लो, है ना? अच्छा सवाल था. कुछ भी डाउट है तो पूछ सकते हो. इफ यू हैव एनी डाउट यू कैन आस्क. क्लियर? कुछ है डाउट? डाउट कुछ है इसमें? अच्छा, ठीक है. If you have no doubt, let's move to the next question. Oh, it's a question. चलो, ठीक है. Before this, all of you know what is limit of sum. What is the shortcut to find the limit of sum? All of you know, na? What is the shortcut to find the limit of sum? Na? All of you know or not? So shortcut is summation. In place of summation, we need to take integration, and other things are r by n. In place of r by n, we need to substitute x, and in place of 1 by n, we need to substitute dx. This is my shortcut for solve the questions of limit of sum. All of you know or not? Yes or no? Are limit of sum? What is limit of sum? By using limit of sum, what we did? It will ask you to find the area in between these. So this is integration from a to b f of x dx. This is the integration to find the what area under the curve, right or not? So first, to evaluate this limit or evaluate this integral, we can use a limit of sum method, that is limit n tending to infinity summation r is equal to 1 to n, and we'll try to bring this function in the form of this summation f of r by n into 1 by n. Then we'll try to bring this r by n in x and take this 1 by n. Shortcut is take this r by n as x and 1 by n as dx. Okay, and it will be giving you, finally it will be giving you some integration 0 to 1 f of x dx, right? So when you are having limit of some questions, so instead of summation, we need to shortcut kya hai? We need to take the integration, and instead of r by n, we'll substitute x, and instead of 1 by n, we'll substitute dx. Clear? So let's solve one questions on limit of sum. Okay? Solve correct? Okay. Let's say question came in 2019 JEE, IIT JEE. है ना? So बहुत ही अच्छा क्वेश्चन था. How we can solve this? है ना? So you can see in your screen, it is asking to find the limit of some a big or very complicated expression, a complicated function. Okay, so if I'll try to write this function as limit extending to infinity, है ना? So मुझे ये पता चला कि यहाँ पे मुझे दिया क्या है, कि मुझे दिया है कि limit to find the limit extending to infinity. That means we need to use the limit of sum method, nothing else. So लिमिट ऑफ सम की जो फॉर्मूला है, जो शॉर्टकट है, उसको यूज करने के लिए मुझे तो क्या करना पड़ेगा, जो गिवन फंक्शन है ना, उसको मुझे समेशन में लाना पड़ेगा, फिर समेशन और एफ ऑफ आर बाई एन के फॉर्म में लाना पड़ेगा, 1 बाई एन भी लाना पड़ेगा. ये सारी चीज मुझे करना पड़ेगा ताकि मैं शॉर्टकट अप्लाई कर सकूं. ओके, चलो ठीक है. सो कैन यू टेल मी इन द गिवन क्वेश्चन it is given that limit extending to infinity, numerator divided by x square into x to the power, n square into n to the power 1 by 3, it is given, and some which is given as 54. Yes or no? Are n to the power 7 by 3, n to the power 7 by 3, it can be written as n square into n to the power 1 by 3 or not? Okay, so if I'll take this n to the power 1 by 3, or if you will divide the numerator and the denominator with n to the power 1 by 3, or what I'm trying to do, I'm dividing cube root of n with numerator as well as with denominator. So what you are getting actually after dividing? Let's see. Okay, so we are getting in the numerator, I am getting 1 by cube root of n plus cube root of 2 divided by cube root of n and so on, plus cube root of n divided by cube root of n. Yes or no? Okay, so now in the denominator you are having n square. So if you multiply this n square inside the bracket given in the denominator, so it becomes n square divided by n plus 1 whole square plus n square divided by n plus 2 square plus up to n square divided by n plus n whole square. Yes or no? It is given or not? Yes, it is given. Now, okay. Now, second further simplification. What I am doing, I am trying to write this denominator in the form of this. Okay, so I am writing first the denominator. Okay, I am writing the first denominator. So in the denominator, if I write this term as 1 upon n plus 1 whole square divided by n square, is there any problem? No. Plus 1 upon n plus 2 whole square divided by n square, no, there is no issues. I can write. So 1 upon n plus n whole square divided by n square. There is no issues. I can write or not? Yes, I can write. And write the numerator as well. So cube root of 1 divided by cube root of n plus cube root of 2 divided by cube root of n and so on, plus cube root of n divided by cube root of n, and final limit extending to infinity. Yes or no? Is it clear? If it is clear, now can we write the numerator and the denominator in the form of summation? We can write or not? Yes, we can write. So how we can convert these numerator and denominator in terms of summation? Let's see what is happening. So limit extending to infinity, to the numerator we can write this as summation of 1 upon n to the power or cube root to the power. We can write this as cube root of n by r by n. Yes or no? We can write or not? R by n or not? We can write or not? Yes. And for the denominator, how we can write the denominator in the summation format? We can write this as simply, instead of this, okay, you can write, okay, one more step I am doing. Okay, so चलो ठीक है, इसको तो कर लेंगे और एक स्टेप कर लेते हैं. Okay, so limit extending to infinity, numerator same है as well as so cube root of 1 upon cube root of n plus cube root of 2 upon cube root of n plus up to cube root of n divided by cube root of n whole divided by, so in the denominator we can write this as 1 by, if we divide this, we can write this as n plus 1 by n whole square, right? N plus 1 whole square divided by n square can be written as n plus 1 divided by n whole square. So this can be also n by n is a plus 1 by n whole square. Okay, so these calculations we will do in the denominator. Okay, if we will do this, what we are getting? 1 by a plus 1 by n whole square plus 1 by a plus 2 by n whole square plus up to and so on a plus n by n whole square. So this is the simplified form till now we got. Now we'll try to write the limit of the numerator in the format of summation. By using the summation, we'll try to write numerator as well as denominator. So numerator becomes summation cube root of r upon n. R is equal to from 1 to n because it is going from 1 to n, 1 2 3 up to n तक जा रहा है. And denominator को क्या लिखेंगे भैया? Denominator can be written as summation 1 upon a plus r by n whole square. A plus r by n whole square. So what I am doing here, I am writing, I am multiplying 1 by n because we don't have any 1 by n with numerator and also with denominator. I am writing or I am multiplying 1 by n with numerator as well as with denominator. If you are multiplying these things, what is happening here? So we can write this as limit extending to 0 summation from r is equal to 1 to n cube root of r by n into 1 by n limit extending to 0 summation r is equal to 0 to n 1 by a plus r by n whole square into 1 by n. So now we can use the shortcut of limit of sum. So what is that? We can directly use, instead of summation we can use integration, and integration from 0 to 1, and this will be limit can be changed now. What we are doing, instead of r by n we are taking x. So when x tending to 0, so my limit from where to where it is going? 0 to 1. 1 by n is, this is extending to infinity. Sorry. So when extending to infinity, so r by n also tending to 0. Yes or no? So this is 0 to 0. So it is same as limit 0 to 1. Instead of r by n, we'll take x, that is cube root of x into 1 by n is my dx. We'll substitute the shortcut, integration from 0 to 1. How we can evaluate the limit? You understood or not? Okay, see here, r is lies between 1 to n. Yes or no? R is lying between 1 to n, right? So if we'll divide n with each term of this inequality, then r by n is lying between 1 by n is lying between n by n. Yes or no? So instead of r by n, we are taking x. So x is lying between, when extending to infinity, 1 by infinity is less than 1. So x is varying between 0 to 1. So limit becomes 0 to 1. So limit integration from 0 to 1 cube root of x dx, and in the denominator what we are getting? 1 upon a plus x whole square into dx. Okay, and limit same. Similarly, we can check the limit. Okay, so now you can easily integrate these two functions or not? Yes, I can easily integrate. So this becomes, if you'll integrate the numerator, what you are getting? X to the power 4 by 3 divided by, because it is x to the power 1 by 3. 1 by 3 plus 1 is 4 by 3 divided by 4 by 3 whole divided by a plus x to the power minus 2. So a plus x to the power minus 2 is a plus x to the power minus 2 plus 1 divided by minus 2 plus 1. Yes or no? minus 2 plus 1. Okay, now you need to put the limit, that is 0 to 1. Okay, so if we put the limit 0 to 1, so what you are getting? So numerator becomes 3 by 4. Okay, 3 by 4, and denominator becomes minus 1 upon this, comes to this side now, minus 1 upon a plus x. Okay, a plus x, here we need to limit, put the limit. So this divided by, this is equal to 3 by 4, 4 divided by, we'll put the limit minus 1 upon a plus 1 minus 1 upon a, right? So finally, after calculations, we are getting 3 by 4 into divided by minus 1 by a plus 1 plus 1 by a, and after calculations, after simplifications, we will get one quadratic expression. Okay, one quadratic expressions you will get, you will calculate, and you will get a square plus a, which is given as 54 na, which is given as this integral is given as what is 54 दिया था, ठीक है? So this is given as 54. Okay, so this is given as 54. Yeah, this is given as 54. We can cancel from here also. This will be 18. This will be 18, and a into a plus 1 goes to this, and after simplification we will get a square plus a minus 72 is equal to 0, and by factorize this quadratic expression you will get a plus 9 into a minus 8 is equal to 0. So we are getting a is equal to minus 9 or 8. Two values for a we are getting, that is minus 9 and 8. So these are your answer. So for values of a, क्या मिला मुझे? जो a की वैल्यू है, that is minus 9 or 8. You can take. Clear everyone? Any doubt? So the simple funda is, shortcut is, first you need to bring that limit in this format, f of r by n into 1 by n summation. Okay, so instead of summation we'll take integration. Shortcut क्या है? Instead of summation we'll take integration, and instead of r by n we'll substitute x. Okay, and instead of 1 by n we'll take dx. Okay, so these three things, when these three things will be done, then the question will be 75% done. You can understand. Okay, clear? Clear everyone? Is there any doubt? You can ask. कोई भी doubt हो तो पूछ सकते है ना. First what we did है ना, just I am trying to bring, or I am trying to apply the summation है ना, or to bring the form of summation into r by n format, 1 by n format. That's I am doing, nothing else है ना. So that's why what we were having in the denominator 8 n to the power 7 by 3. So n to the power 7 by 3 is n square into 1 by n to the power 1 by 3. So what I'm doing, first step, I divided n to the power 1 by 3 with numerator and denominator. After dividing, these expressions I am getting. After dividing n to the power 1 by 3 and also n square multiplied with the given expression in the denominator. After getting, I am doing this. So जस्ट रीअरेंज करके मैं डिनोमिनेटर को ऐसे लिख सकता हूँ, फिर से ऐसे लिखा, फिर ये फॉर्मेट में मेरा आ गया है ना. तो मुझे जैसे ही ये फॉर्मेट मिल गया, सो तुरंत मैं क्या किया ना, इंस्टेड ऑफ समेशन आई हैव यूज्ड इंटीग्रेशन. लिमिट तो पता है मैं कैसे चेंज किया लिमिट को, 0 to 1. ये है लिमिट, कैसे यूज करते हैं, लिमिट को कैसे चेंज करोगे है ना, ये वाला प्रोसेस बता दिया तुम लोगों को. सो डिनोमिनेटर हो गया, बस इंटीग्रेशन किया, इंटीग्रेशन करने के बाद मुझे a की वैल्यू मिल गया, दैट इज -1 -9 और 8. क्लियर एवरीवन? क्लियर? ठीक है, कोई नहीं. ओके, So it's time to end your class now. So we'll discuss so many questions in the next class also. Oh, tomorrow you are having exam, mock test, right? So all the best for your mock test, third mock test, third or fourth, third mock test you're having tomorrow. Huh? So we'll discuss your question paper in class Monday's class session. We'll discuss your tomorrow's exam question paper in Monday's class, and from Tuesday we'll continue our as usual classes, or we'll discuss some questions on definite integrations, or we'll discuss take some advanced questions came into previous year JEE advanced examinations. We'll take those questions and we'll discuss those solutions also. Okay. So take care. Bye bye. Thank you all. That's all for today's class. Thank you. Thanks for your time. Thank you. Bye bye.